Hello students. Today the first chapter in physics I am going to discuss, and the name of the chapter is motion. Student, physics is very interesting subject in which one of the branch is called mechanics. Mechanics deals with the study of motion. Now mechanics is divided into two categories: kinematics and dynamics. Kinematics literally means, and it is a combination of kine plus matics. Kine means motion and matics means calculation. It means calculation related to the motion of a body. Okay, so what is motion in general? When we say and discuss that whenever an object change its position with the time, it is said to have a motion. uh, this is the way this is defined as. Suppose if I am putting this cap of the pen here, and if this object is changing its position with the passage of a time, okay, from this position to this position, then we will say that this object has motion. If we go to the backdrop of the history related to the term motion, actually it is derived from the Latin word movere or motio. These two words are Latin words. From motio, English, in English language, it is taken and motion is come into its existence. So motio means to move from one place to the another place, or from one point to the another point. Fundamentally, there are two categories of motion. Fundamentally, we are having two categories of motion, but in superficial way we can say that it can also be categorized into three categories. But basically we are not going to discuss all those 3D motion types. So motion is having fundamentally two categories: 1D motion, that means one dimensional motion, and 2D motion, that is two dimensional motion. What do we understand by one dimensional motion? Students, motion in a straight line having only one dimension, only one dimension. So motion in a straight line is a one dimensional motion, and it is generally known as rectilinear motion. Okay, and two dimensional motion means what? Here one dimensional motion is clear to you, I guess. It means whatsoever the movement will be taken place in a body will be only having one axis, whereas 2D motion, that means a body is going to have two axis motion, that means motion in a plane. Some of the figures I have drawn here, like here you can see the car in figure 1, which is moving in a straight path. So moving the straight path is example of 1D motion, that is single dimensional motion, that means rectilinear motion. You can see here in figure 2 that a boy is dropping a ball from the top of the roof. This is also a kind of rectilinear motion. Why? Because this is one dimensional motion, This is along the y axis and this is along the x axis. In figure 3 as well, you can see a boy is throwing a ball vertically upward direction. The ball is going to its vertical limit, then coming back to its path. Coming back to its path. So here these two, figure 2 and figure 3, are vertical motion and containing only one axis motion. So horizontal motion or vertical motion, both these are rectilinear motion. Then what is the 2D motion? That means x axis as well as y axis. In figure 4, a boy is throwing a ball and giving the ball at some angle and throwing it along the curved path. Now here this ball is traveling along the x to y. It means two axes is involved, so that is why this motion is 2D motion. Okay, and generally it is known as projectile motion. So in the figure 5 you can see here a boy is having one string and the pebble or stone is attached to it, and he is allowing the stone to move in a circular way. Again, this is the two-dimensional motion. Okay, so this circular motion, this projectile motion is actually a what? Motion in a plane. It means this is the plane. So this plane is getting created because of the two-dimensional way. Okay, students. Now, the next thing that I have written some point, that when an object moves in a straight line, the motion is known as rectilinear motion. Very basic thing. Now, I guess you have understood the concept behind it. Basically or fundamentally, we can conclude that motion is nothing. It is just a change in a position of a body. Motion is nothing, just a change in position of a body. Already I have mentioned about the kinematics. The calculation related to motion of a body is called kinematics. But moving further, we need to understand about the very strong and very important term, that is the reference point. So what is the reference point, student? Suppose you are coming to school from your home, and if anybody is asking that what is the distance between the home and your school, then one point is taken as a reference point, and we can say that origin point. So how are we able to say that this is the distance between the home and our school? So reference point is a place or object used for comparison to determine if something is in motion. Correct? You travel down all the way from your home to school. So you can fix up your reference point as a school or home, and you could say that this is the distance between these two allocation points. Well, students, in this module we will come to know in this kinematics there are some of the important variables of kinematics that we are supposed to discuss here. Number one is distance. Number two is displacement. Number three is a speed. Number four is velocity. Number five is acceleration. Okay. One more variable is there which is known as jerk, but that's not really important here for class 9. So these are all very important in respect of class 9 course. So before going further, we should understand about the nature of quantities. Students, basically there are two kinds of quantities, physical quantities. One is called scalar quantities, so and other is vector quantity. A scalar quantity means those physical quantities which have magnitude only for the complete specification, for the complete specification, where we can, like I'm giving example, if I ask you that what is your height, you say that my height is 5 feet. So 5 feet, the length is enough to describe that physical quantity which is known as height here, right? If I ask you that how old are you, you say that 16 years. So that 16-year is a time period and it is giving the complete information. Okay, so whenever any physical quantity is getting complied by giving the magnitude only, magnitude means what? Numerical value, numeric value, like uh, how many fingers in your hands, we will say that in one hand there are 5 fingers, so that 5 is magnitude, that 5 is a magnitude. Okay, how many teeth do you have? 32 general number of teeth in human beings, so that 32 is a magnitude. I hope that you have understood about the magnitude term. Now moving on to the vector quantity, those physical quantities, students, which have magnitude as well as direction, and magnitude, direction, both these things are required for the complete specification, for giving the complete information about the physical quantity, is called vector quantity. Okay, for example, displacement, velocity, acceleration, so these are the vector quantities. Now moving on to the another set of things, student, very important topic and the last topic for today conceptual class. Student, first of all, what is the terms written here? Position, path length and displacement. Position, path length and displacement. Here let us consider that this is the position of an ant and this is a stretched string in which ant is changing its position constantly. So student, at time t1 the position of ant is p. Okay, now ant move towards and we are having observation for time t2 and ant is reaching to the position q. Now the ant is here at a scale of 4. Okay, now at time t3 again ant is moving back Now ant is moving back and coming to the scale of 3. Try to understand, students. This is a very important concept in understanding the path length and displacement. What have I said? Initially, what is the position of ant? The position of ant at time t1 is p at a scale of 1. At time t2, the position is q at a scale of 4. Now ant goes back to the position r at a scale of 3 at t3 time. So from t1 to t3, what is the path length of ant? We will say that ant has traveled a distance from p to q. So p to q, the distance is 4 minus 1, that means 3 meter. And q to r, 4 minus 3, that means 1 meter. So path length is 3 meter plus 1 meter, that is equal to 4 meters, students. Okay. Now we will understand the term displacement here. Displacement is generally known as the shortest distance between the final position and initial position, and mathematically it is written as final position minus initial position. Suppose that being an observer, you have seen all the observation from t1 to t2, all the way from t1 to t2 and finally to t3. But suppose that along with you there is your friend, and that friend has seen the position of ant at p, and after a moment he goes away and comes back and find the position is as r. That means he has seen the initial position as a p and the final position as r. For him, the displacement will be 3 meter minus 1 meter, right? Because final position is 3, initial position is 1. So 3 minus 1, 2 meter. This is the displacement for your friend. Observation. Students, here again I am taking the example. Let us consider that this is origin, that means a reference point, and has traveled from origin or reference point to the point B and traveled a distance of 2 meter towards the positive of x-axis, correct? At one case. On the other hand, in the other case, the ant is moving from A to C, and now the ant is moving from 2 meter towards the negative of x-axis. So in case 1, displacement of an ant from A to B, what is the displacement formula? Final position minus initial position. So what is the final position in case 1? 2. Initial position is 0. So 2 minus 0, that means equal to 2 meter. Is it a positive displacement? Yes, it is a positive displacement. In case 2, displacement is from A to C. What is the final position? Final position is minus 2. After 0, this is minus 1, this is minus 2. So minus 2 minus initial position 0. So it is minus 2 meter. So we can say that this is the negative displacement. I hope that you have understood this concept. Now students, here very popular question is asked usually in exam, the difference between distance and displacement. The first point is the actual length of the path between any 2 points, correct? And displacement, the shortest distance from initial position to final position of a body. Distance is scalar quantity, displacement is vector quantity. Distance has only positive values, whereas displacement can be positive, negative, and even zero. Distance can be measured along non-straight path. It does not supposed to have only straight path. It can go along with the non-straight path. Whereas displacement can only be measured along a straight path. So conclusion point is, as far as the distance is concerned, that how much ground an object has covered, and in displacement, that it is the object's overall change in position. So that's it today. Thank you, students.